Hello everyone, my name is James, and today I will be going over question 3B from the 2023 Set 1 of the AP Physics C Mechanics exam. So, of course, first thing that we're going to need to do is read question 3, and I'll pause here and let you read it. Okay, so now we are going to read question 3B itself. B. Derive an expression for the linear speed v0 of the sphere immediately after colliding with the rod in terms of the length L and physical constants as appropriate. Okay, so let's draw a few diagrams to get a better understanding of what is happening in the problem. So first we're going to draw this here. So we have the ball, and then we have the rod. And then after that, we're going to have the rod when it comes down and just before it hits the ball or the sphere. And then afterwards, we know the ball is going to be there and rod's going to be somewhere. So that's what it'll look like before, right as, and after. So, of course, we have a sphere and a rod colliding, which should make you think about momentum, and specifically about conservation of momentum. Now, momentum has the symbol P for translational and is equal to mass times velocity. Now, think about any time you see a large car, such as a truck, driving down a road. So, just pretend this is a truck. And if there were a Mini Cooper, which if that's a car, then we'll go, this is a Mini Cooper, truck and a Mini Cooper. Now, if they were driving at the same speed, so V for both of them, and they were to hit an object, the momentum transferred would be so much greater from the truck than the Mini Cooper because of its larger mass. So when it comes to solving the problem, of course, approach it with whatever way you are most comfortable with. I personally like to think of rotational problems in terms of translational problems, and then do the substitutions from there. So if we were to do it like that, we would have P initial equals P final, which of course would be the mass of the initial object times the velocity of the initial object is equal to the mass of the final times the velocity of the final. And this here is conservation of momentum. So here we have the general equation for conservation of momentum for translational impacts. But since the rod experiences rotational momentum, we need to substitute in the proper variables into the equation. Now, I'm going to color code these, so bear with me as I write all this down. So, the conservation of momentum equations now become L initial, because L is the symbol for rotational momentum, is equal to L final. And if we were to plug these into the equations, we would get the initial moment of inertia times the initial angular speed is equal to the final moment of inertia times the final rotational speed. So now what we need to do is set them equal to each other. And that is why the most important part of understanding this problem is the conservation of momentum. So with this, we were able to set up the equation that we just did, and now we can set these two equal to each other. But we need to do some substituting in first. Now, L initial, L naught, is equal to I initial, W initial. But what is that equal to? Now, from the problem here, we can see that the inertia is 1/3 ml squared, and m is 2m. And then this is also the angular speed. I talked to my friend who is doing this problem for this assignment, and this is the answer that they came up with. So we're going to plug those into this now. So we have 1/3 2m L squared times, oh, I'm sorry, this W naught should be in green. W naught times 3g over L. And LF is equal to IFWF. And that is equal to M times L V naught. So now we can set these equations equal to each other and cancel. So if we were to do that, that would be 1/3 2m L squared times the square root of 3g over L is equal to M L V naught. Now, if we do some canceling here, we're able to cancel the m's on both sides, and we're also able to cancel 1L. So that leaves us with the final equation of V naught is equal to 2/3 L times the square root of 3g over L. So a common mistake for students, either from a lack of understanding of the diagram or due to rushing through the exam, would be to assume that the ball will continue in rotational motion, like this here. Now this would leave you unable to find the linear speed. So to help avoid this, practice the 3-diagram method for visualizing the problem that we did earlier. Now this will allow you to obtain a greater understanding of what happens during the problem. So to recap what we used to solve this problem, the conservation of momentum was integral to our solution. So all of that there. That is what allowed us to solve for the final answer. And again, just to reinforce the strength of using diagrams, they are what allowed us to visualize the problem to make it easier to solve. So remember to practice problems as much as you can so physics can just get easier for when you need it. In the description to this video, there will be links for all of the full FRQ tests that were released for Physics 1, Physics C, and Physics C Mechanics and Physics C E&M for 2023. If you have any questions or additional information, or need additional information, please feel free to leave comments and I will answer them. Thank you for watching.